Hello and welcome to another episode of Vibe Codelicious live stream. Let's see, get that out of here. And okay, let's talk about what projects we're working on today. Last time we were doing some work on this image to maze project. This project mostly exists to exercise the Context Bonsai plugin and make sure that it's working the way we want it to, which is that the LLM will spontaneously realize that it's a good time to prune out some parts of context, replace it with a summary, and continue its work. Uh, now, the original development effort completed, it produced the program for the image to maze. We ran it. We gave it like a tangram image of a house and one of a sailboat and asked it to produce a maze for those. And the maze it produced did not represent at all the original image, which is the kind of the whole point of the program. So I went through a debugging session, and it found that the issue was the logic for generating the graph, the maze graph, was not compatible with the structure that it produced to build the graph out of, because it produced a space filling curve that occupied every cell of the maze, and then the next step was supposed to modify, or it was supposed to grow individual cells so that it would create a maze out of the graph that it had, but it wasn't able to do that because every single cell was already filled by the original curve. So the LLM has proposed a different approach where it's going to take the tree and rewire it to match the tree of the maze, I believe, is what it's talking about. I didn't go into it much because it's more or less a program for fun. I'm not making it for real. It's really just to exercise this Context Bonsai plugin. So I'm going to just see what it does. And if it works, I'm going to have it explain to me how it worked, because there are some interesting details of this whole maze making thing. So that's going to happen over here. Let's see. It has produced the plan. I'm going to have it read the orchestrator role and start implementing this plan for fixing the problem. Now, usually at this point, after it creates the plan, I would start a fresh session new so that we don't already consume a portion of our context. We can see right now that the context is 19% utilized. And that means that at the very beginning of the project, of the next phase, it will already start 20% full. But now with Context Bonsai, hopefully that's fine. Hopefully, I'm hoping that immediately when it starts, it realizes it can go ahead and prune away the details of producing the plan. We'll see what happens. But even if it doesn't, as it goes through the project, it should, as it transitions from one phase to the next, it should realize it should be pruning away old things. So this is ready to go. Then the main project is the Context Bonsai plugin. So now that the plugin is working, I would still like to make it accessible to a broader audience. What that means is this plugin relies on some modifications to OpenCode itself. So OpenCode, I can't rely on them taking my modifications and merging them upstream. So I would like this plugin to be distributable and usable without people having to install my own custom version of OpenCode. So I explored ways to make that happen. One of the ways is, part of Context Bonsai is the way it works is, first it enables message IDs, and that lets the LLM see the entire conversation with every message prefixed by message ID. Then it can call the tool and give it the specific message IDs that need to be pruned away. Now, instead of giving message IDs to the LLM is just going to produce a matching text string of the message that it wants pruned away, or the message range. It would provide two different text strings for the start and end. And the plugin itself is going to take that text string and match it against the messages. And if if there's only one unique match, then it's going to figure out what message IDs those were and proceed the same way. If there are multiple matches, it'll feed back the output to the LLM and say, to pick a better match, here's how many messages match to your string. So that eliminates some of the changes that we had to add to OpenCore. It also fixes another problem, which is that adding message IDs to the conversation, just those message IDs consume tokens, which means it fills up the context further, which is particularly impactful when the context is already close to its limits. And it's also impactful even simply if the context is already large, because as the context grows, the LLM performs worse. So just having a certain size context and then growing it by adding message prefixes along the entire conversation is going to, for that instant when it's looking at message IDs, it's not going to have the same performance. And it kind of matters critically at that moment, because that's where it's selecting the proper messages that it wants to prune away. And we want it to be as smart as possible when choosing what messages to prune away and when creating the summary text, the summary that replaces those messages. So I think this new method of searching for the string and finding the message IDs is going to be better. I actually already implemented that yesterday off stream. Now I'm going to implement a few more changes. One of them is we're going to do kind of an ugly hack where there's going to be a wrapper around the plugin, and the wrapper loads some core OpenCode modules that are not typically exposed to the plugin. It's going to load the core OpenCode, what do they call it? Not modules, packages. I don't remember what they call it in TypeScript, but the code that is part of OpenCode, we're going to load it into our plugin, and it's the code that's responsible for dealing with message storage, because part of this plugin involves modifying the original messages and marking them as archived, so that when the conversation is sent to the LLM, the archived messages don't show up in what the LLM sees. So our plugin is going to sort of suck in OpenCode's code and use that to modify the stored messages. And I'm hoping that works. If that works, that's pretty much the biggest barrier to running on the standard OpenCode without any modifications out of band. And if that works, then I'll be able to publish this as a plugin that people can use without compiling or downloading a special version of OpenCode. So that's what this one is. Can I start it now? Yeah. So let's have it read the orchestration thing. Oh, that's the wrong path. Just read.lm conductor/orchestrator agents. So this is going to read that orchestration tool. And again, I'm not clearing the context. And this one is going to be even more interesting. The context is already 45% full, 47% full. So the pruning is going to matter a lot for this one. Let's make sure it has access to the pruning tools now. Context Bonsai tools. Okay, good. So that means I am running the development version and the plugin is configured. So that's great. I'm going to have it orchestrate the plan. Let me just double check that the plan is, okay, yeah, it did the normal validation loop where it goes through several iterations and takes feedback from an adversarial review subagent. So yeah. Okay, orchestrate this plan. Okay, and we have also been working on a different coding agent called Pi. We're adding VI key bindings. The original version was working, but it was missing a few Vim motions that I use a lot when I do editing. So I did a plan to add those features. That plan went through its implementation phase, and now this is ready for testing. There's nothing to kick the agent off to do in the background while we do this. So we'll come back to that whenever all of the other agents are already busy doing stuff. I'll come back here and test the VI key bindings. And in the previous stream, we started another project for the Pi coding agent. We want to add sub-agents to Pi, and I chatted with the LLM about the kinds of features that I would like to have in my sub-agent feature. And it's okay. So it now has gone and done research into the code and figured out whether the things that we talked about are feasible and how to do it. And so it has a description here. And I think the next stage is going to be to have this go through the actual design process, the loop where it produces a full implementation plan and does the adversarial review to make sure the implementation plan has everything needed for LLM agents to be able to fully implement it. I think I won't kick this off yet. I want to review all of this stuff. I think I already did yesterday, but I'll just make sure that I've gone over all of this stuff before we kick off that planning agent. This is sort of the plan for making the plan. So the details here are going to have huge downstream effects to the final product. So I want to make sure I review this. Oh yeah, and this one is just if we have agents busy on all other tasks, we'll get to this. But this is an idea I had for per desktop background application for showing project notes. So on all of my projects, I have this little separate window where I type what this current project is about, and I would like for that just to be part of the background here. And I found something that lets you, in the KDE settings for wallpaper, you can choose an application. There was a special KDE plugin, and I installed it, and it appears to be working. I do have application in the selector where I can choose application as a wallpaper. So we should be able to make a simple program that has a wallpaper back here, and it detects what virtual desktop it's in and displays a different set of notes down here in the corner. And I should be able to make it look nice and pretty and match whatever background image is present. So that'll be the new project here. I have something set up here. I don't remember what it is. Oh, yes. Okay, so exciting news in the LLM world is OpenAI released a new model, GPT 5.4. And they specifically said it was better at certain things, including web design. And I've had a blog design that I have tried to have LLMs produce a working implementation out of. I just have a picture. Oops. And so far, I've not been able to get LLMs to implement this properly. And a huge limitation is I have them create what they think is going to work and then take a screenshot, look at the screenshot, and see if that matches what they think they created, see if it matches my original design. This is the original design for the blog. It has this little like pixely design here, a floating pixel there, a floating pixel down here, more of these stair-steppy things here, and then the posts they fill up this body here. And there's a footer down here, a header up here. And so far, it has been unable to do this. It looks relatively simple, but the coding agents simply can't do it. So one of the big drawbacks is when you give them this image, they have a really hard time counting these stair steps. They also have a hard time understanding the proportions here, and I've tried creating a special document that talks about things in design terms, in terms of proportion and white space and balance, and gets it to analyze the image in terms of design terms, but it still struggles. And it also will very readily take two completely different images and say, yeah, those look like each other when they are extremely different. So it will be interesting to see how the new codex performs, specifically because they said it was good, it was better at web design. So that's what this project is going to be. But I'm not going to start that unless we have space left and the other projects are sort of halted. Okay, so back to the image to maze project. Here, what did I say? Read that. That's how you'll be implementing this. Okay, so now it's doing the GPT thing of I told it what to do, but it actually says it read and followed it. I switched to orchestration mode, no direct implementation, ran the full developer reviewer judge loop for the fixed story. Wow, it did everything. Developer, reviewer, judge. Judge approved as is. Oh, that was quick. Okay. So the next step here is to do the test. I wonder how full the context is. 21%. And I don't see any Context Bonsai tool calls. No, it didn't use Context Bonsai at all. That's fine. It was way quicker than I thought it was going to be. This is probably a project where I'm going to have it create an end-to-end testing plan where it instructs the LLM how to take the original image, produce a maze out of it, and compare the produced maze to the original image. But I'm going to see if it remembers from the last loop we went through. I doubt it does, given that the context is only 21%. I think that was a separate session. Whoa, okay. I check results by running story validation commands and confirming artifacts and invariants, not just in if runs. For this fix, the key checks are runs bun tests. It creates an image. Oh yeah, it understands. Well, no, it's not doing the critical step of looking at the images. That should be enough. And then it should say that it understands that, and then I can tell it to go ahead and do that. Oh no, it's just doing it on its own. Great. There's the opposite of the GPT behavior I've been seeing. Okay. 2, asking permissions for, yes, you have permission. Okay, so this one didn't even start because it was waiting for permission on reading the orchestration framework tool documents. VI key bindings for testing. We'll come back to that if other things aren't doing stuff. Oh, PI subagents. Yeah. Okay. Extensions can register custom tools, commands, shortcuts, and custom UI. Okay, great. So an agent tree and sub-agent controls are possible in the extension space today. Great. There is already a reference sub-agent extension that spawns isolated Pi processes. Ooh, there's a reference sub-agent extension already. That's nice. Streams progress, including single parallel chain modes. RPC mode already has the core primitives. Oh, it already has, okay, it has stuff for communication between agents. The SDK supports programmatic agent session control and queuing behavior, which is useful if we decide to run subagents in process instead of sub-processes. Okay, sure. That's interesting. It does seem like it would make sense if you're running very many subagents to have like an event loop based system, because most of working with subagents is waiting on results. Either you send a message to the LLM API and then you have to wait for it to respond back, or the LLM does some sort of tool call and stuff is happening and you need to wait for that sub process to finish and come back. So an event loop model as the concurrency primitive for handling subagents does sound nice. Um, yeah, interesting. Existing slash tree command is conversation history branching, not multi-agent runtime topology. So your agent tree is a new UX concept. Okay, sure. And here's where it tells me its own idea of what the user gamut and the user needs gamut are. So the users are solo CLI coders, yep, staff engineers orchestrating complex refactors, sure. Reviewers running independent checks, yeah. Infra security conscious teams, sure. SDK RPC integrators building custom UIs, sure, okay. It's kind of a narrow user gamut, but that's fine. This I really am tailoring towards myself. That's kind of the whole idea behind the Pi coding LLM framework, is you make it do whatever you want rather than trying to be general for all audiences. User needs gamut. So these users need fast parallel exploration. Yep. Strict isolation of context. Yes. Traceable lineage of work. Yes. Low cognitive load while many agents run. Very yes. So that is kind of a really critical thing. I constantly get confused because I'm running multiple projects at a time. Um, Specifically because of what I just said. Just like the coding agent itself, most of what it does is waiting. That's true for me too. Like I kick off something on the agent and it takes a while before it's done. And so I switch back and forth between tasks, and the less thinking I have to do about um, what subagents are doing in a particular task and how to manage them, the better. So I'm glad it recognized the low cognitive load here. Predictable cleanup and reaping. Yes. Explicit cost model control per agent. I don't really need that. I don't mind that it's there though. It kind of depends on how much complexity that's going to add to the final thing. I might chat about that part specifically. Okay, features. Subagents as managed runtime objects, not one-shot calls. Create named agents with an identity, a title, a parent link, and a task ID, a mailbox, a lifecycle, and resource ownership. Yep, this aligns with your requirements. Fresh versus forked context, chatting, idle busy visibility, per agent model, provider reasoning, and reaping. Yeah. First class agent conversation bus, parent-child, and child-child messaging events. I don't know if I want child-child messaging. There are situations where I do that. So what it's talking about is there are, it might be obvious that you would want conversations between a parent agent and its child, because you might spawn a parent agent to launch like a research sub-agent to dig into, how a particular subsystem on a large project works and report back. And then you can chat back and forth about that and just keep that sub-agent alive. Or you can have a parent agent that has a developer, and the developer completes work, sends it to the reviewer has feedback, and you can take that feedback and send it back to the same developer agent, and then that developer already has relevant context loaded and doesn't need to start all over from scratch again. But for child to child would mean something like the developer and a reviewer could communicate between each other, or whatever general operating thing that you would do where you would have multiple child subagents cross talking with each other. I can imagine a situation where you have this orchestrator agent that launches a developer agent, and the developer agent may want to launch several peers, or it may want to launch its own sort of experts, where it says, you please become an expert in this one subsystem, you become an expert in this other subsystem, and then the developer can go to those expert systems to get information it needs rather than doing all of the digging around itself and filling up its own context. Maybe that's fine. Yeah. Let's keep child-to-child messaging there. Blocking can still be conversational if the blocking call internally runs an event loop instead of a single wait. I don't know why it has to call this out. Blocking can still be conversational if the blocking call internally runs an event loop. I'm not quite sure what it's talking about between running an event loop and a single wait. Is it comparing it with a one-shot sub-process where you would launch the sub-process and then just wait for it to finish? Maybe. An agent tree runs as an operational cockpit. Show lineage, runtime state, unread question badges, per node model tags. Per node model oh yeah, tags. Yep. Okay. Include operator actions in tree: message, cancel, reap, inspect, transcript. Oh, interesting. So I, as the operator, could go into the tree and pick a subagent and message it. Makes sense. I can actually do that in OpenCode with an awkward interface, the just left-right switching between subagents. Cancel. I don't know that I want the operator to trigger a reap. Yeah, actually that does make sense. Maybe the parent agent forgot about that subagent, and the parent agent itself died. Well, if that happened, I expect the harness to take care of reaping the child. Would I want that, or would I want the child's left alive? Something to think about there. Inspect transcript. Okay. So 3 of these are currently available in OpenCode already, and those make sense. The reap, I have to think about. Reaping as mandatory hygiene. Terminal agents should auto-reap by policy with keep alive override. Okay, an orphan garbage collection should run on restart parent exit. Yes. Keep lightweight tombstones for audit/provenance in the tree. Yes. Important design tension. Worth deciding early. Interesting. Love that it called that out. If subagents are launched as subprocesses, like the current example, oh, that's why it's comparing with subprocesses. The included example for subagents is based on subprocesses. Okay. Isolation is strong and aligns with existing patterns. If subagents are in process, forked context and richer orchestration may be easier, but isolation/fault boundaries are weaker. I don't think I care too much about that. That'll be something to think about. You can also do hybrid, sub-process by default, in-process only for lightweight ephemeral helpers. Definitely not hybrid. Just hybrid is going to make things way too complex. Having multiple modes of launching subagents sounds like a really bad idea for maintaining the project long-term, for being able to reason about it when you're making modifications, for having like special case code? Is this a sub process type or an in process type, and having different things happen for different kinds? I do not really want to deal with that. Creative UX opportunities. Model lanes. Visually group children by provider model reasoning for cost quality strategy. No thanks. Fork bundles. Fork in alternatives from the same. Yes. That I definitely want. So you can have the parent launch several children. They all work on the same task, and then you see all the results and you can rank the outcomes. That's pretty cool. I would like that. But maybe keep it as an implement later sort of thing. Implement later, but think about it as you're producing the current plan, so you don't paint yourself into a corner that blocks that or makes it more complicated. Auto reap policies. Manual on result read. TTL. I don't know how auto reap and manual are. I don't know why manual would be one category of auto reap. That's weird, but agent role templates, scout planner, reviewer, implementer. That's a whole separate feature guy. We'll keep that aside. Oh, well, okay, so it's talking about the UI, what I want the UI to have an obvious way to choose roles. Maybe, maybe. Let's keep that in mind as a let's not block ourselves out of doing that, but not spend a lot of time doing complex things to make it happen. So if this direction looks right, I can turn this into a concise concept spec. Okay, I think I will never want model lanes. I will want fork bundles, but not in the current plan. Actually, let's state it this way. Want these features eventually, but not in the current plan. We should plan such that we don't block the later items. And that would be fork bundles, auto reap policies, and agents role templates. Okay. What else did I note? I wanted to talk about I highlighted something so that I could copy it and talk about it, but it's not in my copy history. Oh, it was something in here. Oh, I think it was this explicit cost model control per agent. Oh, yeah, actually it was. Okay. Actually, I'm going to put that as the future, like a future item that we don't want to block ourselves out of. Okay. Anything else I wanted to call out for this thing? I think we need to consider the different like sub-process versus in-process modes. So I did mention in the previous one that I do want to transition to a like sandboxed execution mode, but I don't think that I'm gonna want a sandbox per sub agent. I think I will want an entire project running in its own sandbox. Oh, actually, that's not true. I'll be able to want to launch research sub agents in their own sandbox that don't have the ability to execute code, but they can go do web searches and get content that may be untrusted, that I can handle in various other ways that have some sort of isolation. Yeah, that makes sense. Okay. In process versus subprocess. I just realized I don't even know what language Pi is implemented in. For some reason, I think it's Python. TypeScript. Okay, if it's TypeScript, we can use isolates. Worker threads track child process of VM context. For your subagents, worker threads. Okay, worker threads gives a nice middle ground, lower startup overhead than subprocesses, good crash containment versus pure in-process objects, explicit message passing. Caveat, TS doesn't change isolation semantics. At runtime, it's JavaScript on Node. You still need a strict RPC boundary and lifecycle supervisor to get the behavior you want. Sure. Let me see. It talked specifically about the trade-off. Where did it have that? Oh, here. Okay, what it meant was sub-processes are the strongest isolation boundary and match the repo's existing sub-agent examples, so they're the most proven path today. Worker isolates are still real isolation. They're separate V8 heaps, but they share the same parent process and operational fate more than sub-processes do. That's fine. That's fine. So the comparison is sub-process, worker isolate, sure. Weaker blast radius guarantees and trickier global process concerns. Actually, I think I even prefer the same fate for all of the workers. This is not like the kind of thing where I want to minimize downtime. Like I have a bunch of processes working, and if some processes die, I want the other ones to continue working so that the load can be distributed to those while the other one like reboots or heals itself or whatever has to happen, recovers from its crash. This is not that kind of a situation. This is where I don't want a random I don't want the parent to die and have a bunch of random orphaned child LLM things. I would rather the entire thing die. And then I can bring it all back. Yep, agreed. Do isolate first based on worker threads. Okay. Were there any other callouts that I didn't specifically address? Fork semantics detail. Exact shape of a fork snapshot. What is considered copied versus referenced, and whether forks start paused or immediately runnable. Oh yeah, interesting. So we could store our LLM conversation, and when we create a fork, um, that forked one can reference the original conversation. We can reference a specific message ID in the original conversation. But if we think about it in terms of context bonsai, that original message may modify some message that happened earlier than the fork happened. And so anything that got pruned in one session would be pruned for any session that happened after that prune point. So um, that's something to think about. We could modify context bonsai so that the pruning is like per session ID type of thing, um, so that you can mark it archived or not archived in particular sessions. That seems to make sense to me. Um, let's go over the fork semantics detail first. Let me make sure nothing else is going to be really critical. How blocking handoff appears in the TUI, who owns cancellation interrupt when parent is blocked. Okay, agent tree behavior, sort grouping rules, collapsed states, what status badges are mandatory. Okay, reap policy defaults. Even if full auto reap comes later, we still need sane v1 defaults. Okay, sure. Per agent titles, who sets the initial title, caller versus auto title? Oh, yeah, the caller sets the title. Let me just answer the easy questions. Um, blocking mode, UX. I'm actually not sure I want the UX to block at all. Um, some agents can handle doing background tool calls. So it can launch a background agent and then still be responsive to additional messages. And then that agent can respond back later saying it's available again. And in fact, oh, well, yeah, let's think about that. Some models can do background tool calls. These don't even need to block, but there still needs to be an indicator that there is some tool call happening in the background. Yeah. Let's see, what else? How blocking handoff appears in the TY. Who owns cancellation interrupt when parent is blocked? Actually, I understand what when parent is blocked means. What I want to know is who owns cancellation interrupt? I mean, we need one clear rule for when a control C is routed and when multiple agents are active. Okay. Oh, I need to clarify what I just told it. Ooh, it's spontaneously doing context pruning. All right. All right. This is exciting. Let's see. The reason decisions were finalized on run tape time. Ah, yes, that's perfect. So we decided decisions based on conversation and it pruned out some stuff. Cool. So it now just puts it in the summary that we confirmed Pi is TypeScript based and agreed to an isolate first subagent runtime using worker threads while keeping a runtime abstraction compatible with future subprocess backend support. We clarified that background tool calls should be non-blocking but visibly indicated in the UI. We also defined interrupt routing concerns around ownership and propagation in multi-agent execution. Okay, cool. Actually, I think this summary might not be enough. So the Context Bonsai summary is supposed to pull out the information that you're going to need later and get rid of the information that you don't. So it says in the summary that we defined the interrupt routing concerns, but it didn't put that definition in the summary. So it might have just eliminated the actual decision and simply said we made a decision, but in order to find out what that decision was, it's going to have to retrieve back the blocks that it archived. That's interesting. If that's what happened there, it means that I'm going to need to make the instructions for how to create summaries clearer. Okay, Control C does a cascade cancel all descendants first, then the active parent. Perfect. Good. I was a little bit concerned that it would think if I can't Control C in a child, then it's going to cancel all of the children and its parent, but I don't want that. Okay, but cascade cancel does describe correctly what I want. This avoids orphan subagents and keeps teardown deterministic. If a child ignores cancel briefly, parent shutdown should wait up to a short timeout, then force call. Yeah, that sounds good. UI should show this as one operation, interrupting subtree, then parent interrupted. This fits the ownership model and cleanly works both in process and future runtimes. Okay, fine. All right, I'm going to probe it a little bit and find out if it remembers the decision we made about interrupt routing concerns. Okay, yes, at a high level, here's what we defined. Ownership scoped interrupts. An agent can directly interrupt its work it owns, not arbitrary siblings. Yep. Propagation direction. Interrupt flows downward through descendants. Okay, yep. Parent-child ordering, stopping. Okay, yep. Background work semantics. Non-blocking background tool calls still need visible state and must participate in cancellation propagation. Okay. If multiple subagents are active, interrupts targeting must be explicit, focused agent versus whole active subtree to avoid accidental global cancels. Yeah, okay. So the core model was tree ownership, downward cancellation, deterministic teardown order. Great, okay, fine. The next thing that it said I needed to talk about, agent tree behavior, grouped rules, collapse states, what status badges, okay. For agent tree behavior, I think we need to lock these decisions. Whoo boy, there's a lot of stuff here. All right. Node lifecycle visibility. When a node appears, when it disappears, and whether completed nodes stay as history. Okay. Completed nodes should stay, but appear ghosted, dimmed, until it's manually archived. Then there is a separate UI for displaying full history, or maybe there's a separate toggle. Oh, they could have different states. All right, let's put this from a user's perspective. As an operator, I don't want children to just disappear. To be able to see that there was a child, and potentially observe its transcript. However, I also don't want a cluttered UI. So I should be able to archive them. And there should be different modes. For showing only active, active and inactive, or all includes archived. Okay. That's just one piece, the node lifecycle visibility. Okay, ordering model. Strict creation order versus active first. I think for my brain, the way it works, I'm going to have it in strict creation order. I need the order to be stable because I have like a spatial memory of what thing was where. But I do want some way to know which ones need input, including like a recency. But I also want it to be clean. I don't want like a bunch of numbers to show the order. Maybe some level of range along hue saturation. That actually does make sense. Oh, and whether children are always nested under original, even if a parent is idle. Yes, they are. Strict creation order, but with a highlight. I'm going to say a vertical highlight. Oh, I already said highlight. Let me grab an example. Screenshot. There. Copy. Come back. Oh my goodness. Okay, there. There we go. Okay, there. Okay, so my idea is busy ones might have a red vertical bar, and the redness can be whichever one has like output something or done a tool call or had some like extra stuff added to the context. Whichever one has most recently done something is the most red, and it fades to the least red. That might get visually overwhelming, but I like the idea, and if it doesn't work out, it'll be easy to undo. Um, and the idle ones are going to have blue or green or some other color vertical bar next to them. And that'll make it clear that these are the ones I need to jump back to and give it additional input so that it can continue. I'd also like to be able to put my own visual indicator there to say, sure, this one's idle, but it's waiting on me to do lots of thinking, not waiting. It's not like going to be just a simple like poke it along to the next thing or answer a simple question so it can continue. Like it will be one where I come to it and I see something like this, a huge thing that I have to think about and respond to, and I would mark that for something that I have to come back to later. Um, 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 okay. Okay, so I think that covered all the operational things. Okay. Next item, selection focus rules. Ooh, you know what? Something I'm going to eventually want in my own agent is sort of like a side panel. Whenever it has a giant list of things that I want to come back to, I want to have that as a side panel so I don't have to scroll up and down, back and forth, and so that I don't lose it where it gets like scrolled away back thousands of lines that I have to keep scrolling up to, because that's what's going to eventually happen here. It's going to be way up there. For now, I can actually do this and this, and I'm already a couple layers deep. There's this list, and then after this, there's the other one that I still have to get back to. Whoa. Oh, jeez. This. Okay. There. And, done. Oops. Whoops. Done. Okay. Now I can go over here. Selection focus rules. What becomes focused after spawn, exit, reap, interrupt, and whether tree selection. Okay. Let's... Actually, it's recording all of this in its context now. This is a lot of items and a lot of detail and a lot of nuance. So I'm right now going to have it create a file for tracking all of this stuff. I don't even remember what this overall was about. It's about UI stuff. Agent tree behavior. Okay, there. Great. So I'm glad we're doing this project on a live stream because this is probably the best example of project planning that I've been able to tackle on a live stream. This really highlights the initial stages of a project where yesterday I kicked off the research project. I gave it sort of the general idea of what I'm thinking about doing. I had it dig into the code and figure out all of the details and what options are available, how it might implement these things. And now it's come back with a huge set of additional things to resolve before we make the full plan. It's a great thing to have on the live stream and something I should probably make a normal YouTube video about how to do this. Ooh, it's having a problem editing files. Okay, so it's writing a Python script so that it can edit files. Let me fix that. Ooh. No, it shouldn't have any issues writing files. Huh. Maybe I launched this agent a while ago. And it still has an old config that doesn't allow it to write files. And it created its own script incorrectly. It didn't do proper quoting. There it goes. Now it can do it. Okay. Interesting. I think maybe let's quit this and resume. Yes, okay, now it can edit files. All right, yeah. So the next thing to tackle is the selection focus rules. Here's a concrete selection focus model that stays predictable in a tree UI. Single focus only. Exactly one node is focused at a time. That's fine initially. I think eventually I do want to be able to have multiple windows and see the agents sort of interacting back and forth, but I can probably add that on. I don't think I want to bother talking about that now and sort of treating it as something we need to think of in the future. Focus survives state changes. If the focused node becomes inactive, keep the focus there. Yeah. Well, with some caveats. So this is one of the irritations that I have with OpenCode. It will launch a subagent, and the focus remains on the parent, which is great. That's what I normally want, until the subagent has to ask a question or get permission. Then it will switch to the subagent, and I'll be able to answer the question, and then it sticks there, and I don't realize it. And then the agent finishes and just stops there, and I'll ask, why did you stop? And it said, I finished it. And I look at it, and it's only done one task. And I say, you haven't finished it yet. You only did one thing. And then I realize, oh, this was the developer subagent or whatever. It's a little bit irritating. Maybe if the child becomes idle and the parent becomes active again, I want something in the UI. I don't want it to flip back automatically, or maybe I do. I would at least want something in the UI to say the parent has taken back over and let me switch over to the parent easily by clicking or hitting a key or something. Focus never lands on hidden nodes. If filter hides focused node, move focus deterministically. No, that I don't want. That, if the focus went to a hidden node for some reason, then I want the node to become unhidden. If filter hides focus node. Oh, I think that means, oh, if I currently have a node that is focused and inactive, and I go to the tree and I hide the inactive ones, then the current one should move to some non-hidden node. That makes sense, I guess. Sure, yeah. Focus is UI local marking. Archive actions do not change focus unless the node becomes hidden. Okay, sure, that makes sense. Deterministic refocus when hidden. If the focus node is filtered out, focus fallback order. Next visible sibling in creation order. Sure. Well, no, I want to go back to the parent. Previous visible sibling, nearest visible ancestor, first visible root node. If no visible nodes remain, focus becomes none and list shows empty state. To the next visible ancestor. Okay, so that's one item. Did I have anything for this? Single focus only? Yep. Focus survives state changes. Yeah, focus never, sure. Yeah, okay, all of that was fine. Filter switching, changing filter tries to restore prior focused mode if it, no. Okay. I do not want to, so it's suggesting that if I have a node focused, I change the visibility so it's hidden, which means the focus goes to another mode, and then I change the visibility again, it would flip back to the node that was focused before. I don't want that. That's just, for one, confusing to have happen in real life, like as an operator doing it, and for two, that sounds pretty complicated to implement with lots of gotchas along the way, like special cases. Filter changes should not auto-expand collapsed branches unless needed to reveal a focus target. That's fine, although I don't think that's going to happen due to the fact that I don't want a hidden thing to be refocused, so I don't think that's ever going to happen. I'll just highlight that. Given that I don't think the auto expand thing applies because unhiding doesn't move focus. Okay. Create spawn behavior. Your new child creation does not steal focus by default. Optional command spawn and focus can explicitly move focus to the new child. Do not implement spawn and focus. That's just extra garbage that we don't know what we need, so don't do that. Background events from other agents never steal focus. That's fine. Archiving a non-focused node. No focus change. Right. Archiving a focused node, apply the fallback order. Sure. Unarchiving does not steal focus. It just makes the node eligible again. Yes. Keyboard semantics. Up, down goes previous, next visible row in the strict creation render order. Makes sense. Left, right. Collapses or expands the parent. Okay. Enter opens the transcript for the focused node. Good. Well, opens the transcript. Let's talk about the difference between that and letting that node have focus. And what did it call it? Okay. Keyboard semantics. Oh yeah, focus movement is always within the current filter scope. Yes. If you like this, I'll add it to the tracker under, okay. There. Make most of it, but here are some notes. Okay, these constraints make the model clearer, updated direction, refocus when hidden, jump to the next visible ancestor, not sibling scan. Filter switching, no focus restoration when previously hidden nodes reappear. Spawn and focus removed. On your key point, should be the same thing. Okay. Use one concept. Active node equals highlighted in the tree, and the transcript pane is shown, and it's the input target. Perfect. There's no read-only transcript while typing into another node mode. Yes. Any action that changes the active node changes the transcript and input ownership. Yes. Yep, no accidental misrouting of prompts. That's the main thing. I already have enough problems sending the wrong prompts to the wrong agents, so that would make things much worse. I like this way. No accidental misrouting of prompts, no ambiguity about where enter goes. Yep. Interrupt ownership is obvious because it follows the active node lineage. If you want, I'll codify this. Yep, go. Okay, boom. That one is done. The next one's going to be state model per node, exact statuses, and a badge priority when multiple conditions apply. I'm wondering if I want a badge priority or if I want specific lanes dedicated, and we can rather than have a priority, have a physical space for a particular badge. Okay. Next, let's cover the state model per node decisions. Oops. Okay. A concrete per node state model that should fit everything decided so far. Node state model. Execution state can be busy, idle, done, failed, or canceled. I'm going to ask it specifically for examples of these states. Busy is obvious. Idle is obvious. Done is not obvious, nor failed. Canceled may be obvious. I would just consider that idle, because usually the way you cancel it is you hit escape or control C, or it depends on which coding agent you're using it, but whatever it's currently doing, it might be doing a tool call, or it might be responding that whatever that cancel action happens cancels it, but then it just becomes idle, so it's almost the same thing. Busy is obvious. A tool call is happening, or an API call is happening. That's busy. Idle is obvious, ready for input, and not busy. What is done? Failed. Cancelled. For your workflow, treat done, failed, canceled as inactive reasons, not separate operating modes. Okay. maybe it's still hard to tell the difference between done and failed. There's no natural, like, there's no programmatic difference between done, failed, done or failed. I guess canceled you can determine programmatically. Um, but done and failed would have to be like LLM assigned, and I don't know if I want that because it would probably require having a whole separate tool, and the LLM would proceed and finish its task and then call the tool and either say done or failed. Actually, maybe I do like that because either the child LLM itself can call a tool to set that, or it would require the parent to read what the child did or read what response the child gave and think on its own about, okay, was that failed or did it complete successfully, and then it can continue. I guess most of my workflows do that already. Okay. Busy, idle. Okay. Inactive reason, optional. Why it stopped being active in this run. Okay. Agent reached a planned stop condition. Explicit task complete max steps reached normally, or supervisor closed it as finished. Failed unrecoverable error that ended the run. Provider error not retired. Oh, right. You can fail because like the API, the service like OpenAI stops working. It has an outage, and so the LLM calls can no longer be made, and it usually will retry a few times, but it has a max number of retries and then stops. That could be a programmatic way to go to a failed state. Tool crash without recovery. That doesn't really happen. If it runs a tool call and the tool call doesn't work, then control goes back to the LLM, and the LLM usually then proceeds with trying a different tool call, or saying, I can't do this, here's what I was trying to do. So I don't know about that part, but I do like the provider error thing. Canceled means the operator system interrupt. Okay, yeah, that I do like. And I do like the idea that it is an inactive reason and not its own failed mode. Done, failed, canceled, only when a run ends. So this is not really giving me the details of how it enters the done state. Well, okay. The done must be tied to an explicit run loop termination conditions, not vibes. Here's a concrete agent cycle flow and where exactly done is set. So idle starts with idle, receives user or supervisor input, then it goes into busy, it calls the model, processes events, does tool calls, blah, 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 and then goes to idle or inactive. Programmatic conditions for done. Set inactive reason equals done only when busy exits through a successful terminal gate. Natural model stop with no pending work. Model emits a final stop, end turn, or equivalent. Okay, no unresolved tool calls, no follow-up cycle requested by the policy. Step budget completed successfully. Agent reached configured max steps. Um, um, oh, max steps. Maybe how many back and forth calls can happen to the LLM? Man. Um, okay. Okay, let's also look at these. Goal contract satisfied. Same thing. How do you know that the goal or contract is satisfied? That's an LLM decision, not a programmable harness thing. Max steps is not an LLM concept, it's a harness orchestrator guardrail. On the agent loop, what it means in practice, the harness runs a loop, model call, maybe tool calls, model call back and forth. A step is one full loop iteration. Max steps is just a counter. Okay, so that part's fine. You could do max steps, but I don't want to implement max steps. Done should be entered only on explicit harness completion signals like supervisor says finalized success. Again, whoa. Okay, so, oh, right. I tried to narrate this in case people are listening and not watching. So I said I don't want to implement the max steps. It's talking about the loop, like how many times, how many turns back and forth API calls you can have. I don't want to implement that. So I don't want max steps to be like the done condition. And then I said, it looks like you're expecting the LLM to switch the states rather than it being a purely programmatic state identification. And it says to that, yes, state is purely programmatic. LLMs do this all the time. You say one thing and it agrees with the opposite of what you said. That's what it's happening here. It says state is purely programmatic, owned by the runtime harness, never by the LLM. A clean model for you. Okay, busy is set by the runtime. Yep. Idle is set by the runtime. Yep. Inactive reason set only by runtime control actions. Done. Supervisor / runtime explicitly marks the task complete. Again, what decisions is the supervisor or runtime making? This is ridiculous. Failed. Runtime catches unrecoverable error. Sure, we can do that. Canceled. Runtime interrupt kill patch executed. Kill path. Okay. Okay. So I'm saying forget the canceled and failed. Those are fine. They're clearly, we can do programmatic things for those. But the done state, it says the supervisor or runtime explicitly marks the task complete. Again, it seems to think that the supervisor has some sort of brain in it to know that something is complete. So I'm asking it how the supervisor knows the task is complete. Great question. It can't know by default. Completion must come from a defined contract. that opens up a whole like wild bit of complexity. So done should only be set if one of these programmatic contracts is satisfied. Operator explicitly marks the node complete. Sure, that is a possibility, but useless. Parent complete. Parent agent supervisor sends a complete child command. Okay, why not just reap the child? Workflow complete. Node was launched with a concrete completion predicate that evaluates true. In order to do that, you're going to have a different predicate for whatever task you're launching, and that's relying on the parent to think of an appropriate predicate that is meaningful and will accurately trigger on completion of the task. I don't trust that. And it's suggesting things that should not be set as done, which would include the model saying I'm done. It could include the model stopping, model stop reason alone, or absence of more tokens. Those can be hints, but not authoritative. So the rule is done equals external contract satisfied, never LLM seemed finished. Every child must declare completion mode. Operator, parent, predicate, and only that mode may transition to done. I can imagine a use for the predicate. I just don't trust that it would actually work. But in the people that do the Ralph Wiggum style, the real Ralph Wiggum style, that kind of it does this thing. There's this style of LLM coding where you define a set of goals and tasks, and the agent is supposed to proceed through whatever the next unfinished task is. And there's an external loop that keeps launching a new agent, and it says do the next task, and it goes through all of the tasks, and the last task in there says something like say this, and it gives it some sort of statement. So the agent will start, and it will see that that's the only task to do, and the task just says say I'm done, and the agent says I'm done, and then the external loop can detect that output and finally finish. That's how people do Ralph Wiggum style, and that's where this predicate thing could be used, but I don't do that style, and I don't think that's worth implementing at this point. It could be interesting for the future. However, somehow currently you are able to launch subagents, and the subagents do complete somehow, and the control returns to the main agent. So there is something that happens. Maybe I'll just need to understand what's happening there, and that can be the done state. Okay, let's so I described what happens on current coding agents. the parent will launch a subagent. The subagent does a task, and it finishes somehow, and then the parent agent continues after seeing what the subagent says. Whatever happens there, that transition from where the subagent finishes and then the parent takes over, I don't understand. I wonder if there's a special token or some sort of control thing that's emitted by the LLM to indicate its doneness. A control flow event, not a semantic truth about the world. Typical pattern in agents. Parent spawns the child runs its own loop. Child exits when its loop reaches a terminal runtime condition, not when the model claims success. I think it's making stuff up. I'm gonna have this launch a subagent to look at the exact details about how OpenCode does this. Oh, or Pi has its own, right? Oh, I didn't mean Pi itself. I meant the example subagent thing that's shipped with it. Okay, let's see if it figures that out. This subagent may just return saying Pi doesn't do subagents, because it kind of needs the extra step to find that there's like an example subagent implementation that's not really part of Pi. We'll see what happens. So while that's exploring, it's going to take time, and it's a good time to end the live stream here. So we made small bits of progress on the image to maze project, and that's ready for actual testing. The Context Bonsai project is once again asking for permission. I'm going to allow that, always confirm. But Context Bonsai plugin is in the process of putting ridiculous hacks in there that I would not want in a real production system, but this is specifically to let people use Context Bonsai on the stock OpenCode unmodified. So the hacks are there for that, because the deal is, in order to get any changes upstream, I'm probably going to need users that are using the plugin and like the plugin, and I'm going to have to show clear details about why the plugin needs the modifications and why alternatives are suboptimal. And that will likely convince the maintainers of OpenCode that it's worth taking on this change, because every change that you add, it needs to have some value that makes it worth continuing the ongoing maintenance. Every change you make is an opportunity for bugs, is another bit of code that needs to be maintained long term, that affects down like later changes that happen. So in order for this to be convincing at all, I need users. To get users, it'll be better if they don't have to install my custom OpenCode. So that's where the Context Bonsai plugin is standing. VI key bindings for Pi we didn't make any progress on, but I'll probably just test that off stream and report back whether or not it worked. If it didn't work, then I'll show debugging happening on the stream. And if it did work, that's probably the end. I doubt that I'm going to discover any additional editing motions that I want. I think I pretty much covered the things I use frequently when I'm editing. So that's where the VI key bindings in Pi stand. And yeah, now we're back to the Pi subagents conversation. So yeah, this is great. I'm going to continue this off stream and try to get through all of the questions that are currently open and get to the next phase. This has been a good example of this sort of phase of my overall development cycle of how I get stuff done with LLMs. Thanks for joining me. See you on the next stream next week, 11 a.m. Pacific time.